Hello, welcome to the third day of Big Bang Week. My name's Adrian Turpin. My day job is the director of the Wigtown Book Festival. We are here in Wigtown, and one of the reasons that we do Big Bang is that we are in the wonderful, under the wonderful dark skies of southwest Scotland, next to the Galloway International Dark Skies Park. And this festival is going out over the world, but we hope it's also a celebration, particularly of Scotland's dark skies. I'm going to introduce you to someone who probably needs no introduction to people tuning in today. Chris Lintott. I don't know which order to do this in, but co-presenter of Sky at Night, professor of astrophysics at the University of Oxford, research fellow at New College in Oxford, but also a fantastic writer. I've just been reading Chris's wonderful book, which he's not talking about today, but that's even more reason to go and buy it from our bookshop, The Crowd and the Cosmos, which talks about his citizen science and his role, which I'm sure we will talk about later, about bringing in ordinary, I use that in inverted commas, people to help in scientific projects. What we're going to be talking about today is, are we special? It's a question. Are we special in the universe? It's a question that we normally is normally posed in a slightly different way. Are we alone? So I'm really interested to see what Chris is going to say. He's going to talk to us for about half an hour. And then we're going to have a little chat. Please, we have a questions on the side of the chat. If you look, please put your questions in good time, and we'll try and get through as many of them as possible. In the meantime, what I'd like to do is say thank you so much for coming today, Chris. Welcome to Wigtown, at least digitally, and I'll see you in half an hour.
Thanks, Adrian. It's always good when the talk starts with the book plug so that I don't have to do that. But thank you very much for that welcome. And it's great to be. I'm a big fan of Scottish dark skies, so it's nice to at least visit virtually. Hello, everyone. Thank you for taking some of your Friday afternoon to think about the universe. And it's been, at least for me, a pretty long week. So I'll get the headline out the way first. There's one thing I want you to take from this talk, and that is that space is really big. And I mean that really quite seriously. I think it's something that comes naturally when looking at the sky, this realization that we live in this vast and, in many senses of the word, awesome universe. So if we can have the first slide, let's do that. Let's look at a gratuitous shot of the night sky. And what you'll see in a second, I hope, there we go. This is a nice bit of the northern sky. We've got a field of stars of all sorts of brightness. We've got gas, the raw material from which we can make more stars. And actually there's some dust there as well, some sort of tiny particles about the size of sand grains on the left-hand side of the image, blocking out the distant starlight. But this is a view of our galaxy. And we know that the sun and our solar system is just one of a few 100 billion stars within our galaxy. So even from the darkest sky, you might see maybe over the course of the night, a few thousand stars. You're seeing a tiny fraction of the whole. Our galaxy is a few 100 billion stars across. If we go to the, I can do the next slide, that's good. This is where we think we live. This is our best map of the Milky Way galaxy. It's a spiral. Appropriately for a Friday evening, it's got a bar at the center, and then it's got these spiral arms. So there are a couple of strong spiral arms, and then a few scraggly bits, which maybe we'll call arms, or maybe they're just substructure. And we live halfway from the center to the edge of this pancake-shaped disk. So we've had to realize, as we've come to think about the universe as a species, that not only is the sun one of a few 100 billion stars in the galaxy, but we're not actually anywhere particularly interesting in the galaxy. We're certainly not at the middle, but we're not in one of the arms. We're just sort of off on something called the Orion Spur. And there's nothing special about our position. The rest of the galaxy, if we got rid of the sun and the solar system, something I don't propose to do today, but if we did that, the rest of the galaxy would not care. Nothing would change. And so we are adrift in this rather beautiful galaxy, what used to be called an island universe. But of course, you know, I suspect, that our galaxy is one of only, is just one of very, very many in the observable universe. So the shot on screen now is the Hubble Deep Field. This is one of the deepest images of the sky ever taken. You use the Hubble Space Telescope and allow it to accumulate light over about the course of a week. Almost everything in this image, I think there are 4 stars here, but every other dot and speck of light that you can see in this image is a whole other galaxy, another island universe of a few 100 billion stars. And there are as many galaxies in the observable universe as there are stars in our galaxy. So there are 100 billion stars in the galaxy, and there are 100 billion galaxies scattered throughout the universe. And at this point, hopefully, you A, agree with me that space is big, and B, you start to get that slightly uncomfortable popping feeling in your brain as you try and contemplate 100 billion systems of 100 billion stars each. So we can usually at this point, as a science writer, we would reach for analogies. So I'd try and somehow make this number graspable to you by saying things like, there are as many stars in the universe as there are grains of sand on the Earth. But I don't like that approach, and I don't like that approach for a couple of reasons. One, it turns out that that's actually a really contested question. We don't actually know how many grains of sand there are on the Earth. If you go online, there are heavy debates between astronomers and geologists trying to establish whether there are, in fact, more stars in the observable universe than grains of sand on the Earth. So it's not a great analogy. Second, I don't know about you, but I can't imagine how many grains of sand there are on the Earth. It sounds like a lot, but I start thinking about deserts and then my brain sort of breaks down a bit. I can't even work out how many grains of sand there are on Torquay Beach where I grew up. So it's not very useful. What I want to do, though, I think, is tell you that I can't imagine the scale of the universe either. I think astronomers have benefited for a long while from a reputation of being clever. It's actually one of the things, if I tell people that I'm an astronomer, on a plane or in a taxi or something, there are 3 likely answers. The first one is, do you know Brian Cox? Yes, but he's a particle physicist, but fine. Second, people say, are there aliens? Don't know, we'll talk about that in a sec. But the third one is this weird reaction where people say something like, you must be really clever. And that's kind of gratifying, but it's also a bit weird. And I think it comes from this idea that because I can say glibly that there are a few 100 billion galaxies, each of which contains a few 100 billion stars, I think that sometimes seems like I have some comprehension. I just get used to saying the numbers. And this vastness of space does, even for me, who thinks about it every day, create this weird tension with thinking about our position on this fragile little Earth that lives in the midst of this cosmic vastness. So the question for today is, are we special? Is our place in the universe special? But it might be best titled as Cosmic Loneliness and How to Deal with It. So that loneliness, for me at least, has become a bit more acute recently. I now go out and I look up at the night sky in a very different way from how I did even 5 or 10 years ago, because we now know that most of the stars in this image, we now know that most of the stars that you can see when you go out and look up on a clear night, whether that's from the middle of a city or a nice dark sky site, when you go and look up at the sky, we now know that most of the stars that you see have planets going around them. Now, to some of my colleagues, that's maybe not surprising. The physics and the chemistry that sculpted our solar system is the same physics and chemistry that operates throughout the Milky Way galaxy, throughout the universe. And so maybe it's not a surprise, if you're a particularly theoretically minded person, it's not a surprise that, we've ended up with planets everywhere. But until a few years ago, it was a hypothesis. We didn't know that what we were looking at was a galaxy that was filled with worlds. So the 100 billion stars in the 100 billion galaxies have a large number of planets. And looking at this image now, it's hard for me not to see a map of possible worlds that we could explore, an image of places we could imagine visiting, places where you could set sci-fi novels apart from anything else. And I can even show you some of these planets. So this is an image of a star called HR 8799. A running theme of many of my talks is that astronomers are terrible at naming things. Actually, this is sort of not an image of the star HR 8799. It's taken with an instrument called a coronagraph that creates an artificial eclipse, so it blocks out as much of the star's light as possible. This particular coronagraph is on a European telescope that's in Chile. It's called the Very Large Telescope. We're building the Extremely Large Telescope. Like I said, we're not great at naming things. Anyway, the VLT took this image, and the star's light has been removed, so you can see these 4 blobs around the edge. And if I click between images that are made at different times, am I going to be able to do this? Do they move? No. Okay, I can't show you them moving, but these 4 blobs that you see, the one out to the left and then the 3 brightest ones, those are planets. They're Jupiter and Neptune-sized planets in orbit around this star. Now, for most of the planets that we know about in other solar systems, I can't show you them directly. This is an exception. It's a nearby star. The planets are a long way out. The problem isn't that the planets are too faint to be seen. If they were on their own, we'd be able to pick them up with our telescopes. The problem is they're next to bright stars. And so the glare of the star hides the planet. So it's roughly like, and I've done the maths on this, it's like looking at a football stadium floodlight from about a kilometre away and then trying to pick out a glowworm that flies across it. It's really difficult. So what we have to do is we have to find indirect ways of inferring the fact that planets are there. So this is one such detection. This is a detection of an object called the Sun, which I know you see in Scotland occasionally. This is a particular image from a day in 2012, taken from just outside this building in the university parks here in Oxford, on a day where Venus, that's the black dot, passed in front of the Sun. This is called a transit of Venus, and it happens, if you're lucky, at most twice a century. So I would bet, the next one's about 100 years away, I bet that no one in the room will see the next transit of Venus. But we saw it on tour in 2012, it was very exciting. And on the right is a physicist's view of that. So we took a light meter out from the lab into the park and just measured the brightness of the Sun. And what you can see here is that, and that's over time, so as Venus encroached on the disk, the Sun got slightly dimmer. This is what I mean when I talk about astronomers not being hugely impressively intelligent. This is an experiment to detect a planet, but all I've just told you is that when something's in front of the Sun, it gets a bit dimmer. It's not rocket science. Anyway, the point is we can play this game with other stars. If we monitor the brightness of many stars over a long period of time, then we see repeated patterns of dips as a planet orbits the star again and again and again. And each time it does, we get a blink. And so if we see this repeated pattern of blinks, we can say, there must be a planet there. And we can even work out the size of the planet and how long it takes to go around the star. So we see the distance between each blink. So this is called the transit method. It's been the main, not the only way, but the main way that we've discovered planets in the last few years. And it's how we've got this result that most stars have planets. You can even help us do this yourself. I'm not really talking about citizen science tonight, but if you read The Crowd in the Cosmos, which is the story of us getting everyone involved in this scientific journey, then you will find that there's a project called Planet Hunters. You can go to planethunters.org right now. You can help my PhD student, Nora Eisner, find planets by looking for these dips. So this is data from one star over the course of a month, measured by a satellite called TESS, little telescope in orbit. And the dots here are the measurements of brightness of one star. So when they're higher, the star is brighter. So you can see it's really noisy. We're operating right on the edge of what the technology could do. The star itself has star spots and pulses a bit, but in color here, there is this dip in brightness, which is due to a Neptune-sized world that we discovered, which is really, really nice. Actually, this one was discovered brilliantly by a 70-year-old retired policeman from Northumberland, Ray Jackson, who was interviewed on local radio about this discovery. And he was asked why he decided in his spare time to try and find planets. And he said, well, I'd done all the gardening and there's nothing good on television, which I think is sort of the most wonderfully grumpy British reason for discovering another solar system I can imagine. And so it does illustrate the point that these things are common enough that because you're bored of pulling up weeds and you've got a spare 5 minutes before the next episode of The Sky at Night is on, you can now go and discover a planet in your spare time. So I highly recommend Planet Hunters. But to come back to my point, we've now got this idea that the Earth is one of billions of planets in our galaxy alone. And so the only thing really that at first glance distinguishes the Earth from all of these other planets is it's the only one that we know of that has life. And the only one that we know of that has intelligent thinking beings on it. And my usual definition of intelligence is a society that's advanced enough to produce gin and tonic. So that's sort of the barrier that we're aiming for here. And this is weird because if we have 100 billion planets, 100 billion galaxies, each with 100 billion stars, each with maybe conservatively a few 100 billion planets, then aliens should be really obvious. If life is common in the cosmos, if intelligence is common in the cosmos, then we should see ships flying all over the place. We should be visited by now. Somebody should be, hassling us for our intergalactic council tax and so on. And yet we don't see anything. We don't even see anything when we go looking in detail. So this is the Parkes radio telescope, the dish, if you've seen the film, in Australia. And a large part of the time on Parkes and on a big telescope in West Virginia, the Green Bank Observatory, has been used in the last few years to carry on what's now a 30 or 40 or 50 year program of SETI, searching for extraterrestrial intelligence, looking for signals that might be from other civilizations. We haven't found anything. We haven't even found anything that's suggestive that there's intelligent life out there. We're building new telescopes that will be sensitive enough to pick up airport radar on nearby planets. And so maybe we'll find something then. But for now, we've drawn a blank. And given that there are so many planets, this is confusing. And an obvious conclusion is that we are special. That actually, in this entire universe, or let's be modest, at least in our galaxy, despite this profusion of planets, maybe the universe has produced nothing that's as brilliant and intelligent and wonderful as us. This seems uncomfortable looking around the world right now, or indeed at any point. It's also seems to me unlikely because life on Earth got going a long time ago, and yet we've only just started to reach the gin and tonic point where we can be considered intelligent. And so it seems likely to me that if this was happening all over the place, somebody would have got there first. And so we need to think about ways that our planet might be special, that we might be able to explain why we happen to find ourselves here. And apparently, at least, life doesn't exist in the cosmos. Now, there are a few possibilities. I'm going to talk through just a few. The first one is that life may well require a particular range of temperatures. We're pretty sure that our kind of life, at least, needs liquid water to exist. We need liquid water to enable the chemical reactions that produce and form even basic life. And so we can think about maybe in these planets, these other planets, maybe they're not in places where liquid water is possible. Certainly in our solar system, if you think about Venus, the next planet in, it's a hellhole. It's on the surface, it's hot enough to melt lead. If you stood on Venus, you'd be crushed by its atmosphere, dissolved by the acid rain, and you'd asphyxiate pretty quickly. Mars, the next one out, well, Mars used to be an all right place to live. Mars used to be a wet world with oceans, probably long-lived ones, and water on the surface. It's not like that today. These days, it's a pretty arid desert. And for all of Elon Musk's bluster about wanting to go to Mars, I suspect, for at least in the near future, it's not going to be a very pleasant place to be, although I'd love a lift, but mainly for scientific exploration. So we can sort of quantify this. So my friend Elizabeth Tasker, who's a British astronomer who works for the Japanese Space Agency, has sort of thought about this formally, and she invented the Ecclewatts zone, which is the region around a star where Earth would have liquid water on the surface. So if I clap my fingers and transport Earth to one of these other stars, so it orbits the star instead of the sun, then we can say, okay, what's the region around the star where a planet the size of the Earth, with the composition of the Earth and the atmosphere of the Earth, would retain liquid water? Those are sensible candidates. So maybe we can narrow down the list a little bit. But the thing is that we now know of enough planets that we can answer this question. We can say how many planets are within this sort of Goldilocks zone, the bit that's not too hot and not too cold around a star in our galaxy? And the answer is still at least a million. Sorry, at least a billion. So even I get big numbers confused. So at least a billion Earths are out there. So we still have this position where we feel special, where we're lonely, because as far as we know, these other billion Earths haven't produced life. Maybe there are other things about our solar system that make us special. One possibility is that it's not the Earth that's special, but it's Jupiter. So we have this giant planet that lurks in the outer solar system. Here it is. And in this composite Hubble Space Telescope image, we've got a picture of the planet and then a string of objects on the right. This is comet Schumacher-Levy 9, which in the early 90s was discovered not as one comet, but as a string of what brilliantly are called cometlets, bits of comet. And it turned out that this comet had been ripped apart by a close encounter with Jupiter, and actually it hadn't escaped completely. So these bits of comet ended up colliding with Jupiter with remarkable results. So it happened on the far side of Jupiter, so we didn't get a direct view from Earth. But over the course of the next few weeks, Jupiter developed what are essentially enormous bruises in its atmosphere. We watched for the first time a comet impact another planet. Now, my point is that it shouldn't be surprising that this was Jupiter, though the Earth, as the dinosaurs found out pretty quickly, does have impacts from asteroids and meteorites and comets. The most recent famous one was a smattering of meteorites that fell over Gloucestershire about a year ago, last Monday. The overwhelmingly most common fate of something entering the solar system, like a comet, is that the big planet gets hit. And so Jupiter hoovers up a remarkable number of comets and asteroids. So the flux, the number of those that hit Earth, is much reduced. So if you took Jupiter away, then you'd get a dinosaur killing event much more often. Not that I mean they kill the dinosaurs each time, but something big enough to really disrupt life on Earth. And so maybe if you don't have Jupiter, you can't develop intelligent life because you get close and you get close and then bang, you're back to little rat-like mammals scurrying around and you have to start again. We don't yet know, because it's hard to find Jupiters, how common Jupiter-like planets in Jupiter-like orbits are. So one prediction, if you don't want to be special, one prediction is that Jupiters will turn out to be rare. Another possibility is that when you look at the Earth from a distance, and this is a picture from taken from Mars, this is a camera called HiRISE on Mars Reconnaissance Orbiter looking back at us. When you look at the Earth from the distance of Mars, we're a double planet. Right? There's the Earth and the Moon. And the Moon is unusual in our solar system. So there isn't another system in any of the major planets has a moon that's as big compared to the planet as the Moon is to the Earth. Pluto and Charon also are pretty close, but Pluto is no longer a planet, and we can fight about that later if you like. Anyway, the point is that it's rare, for, as far as we can tell from our solar system, for the Earth, something like the Earth, to have a big moon. And the moon does all sorts of things for us. It keeps us stable. So it keeps our climate stable over the course of millions of years. It creates tides. One of my colleagues here, Steve Balbus, has an idea that life on land depended on there being large tides, because that's how fish get washed up and slowly begin to evolve to these tidal environments where they're sometimes wet and sometimes not. The moon also reduces the number of asteroids that it has. And you can make various arguments that the moon is the crucial thing that makes Earth habitable. And we're not yet at the point where we found this sort of system. It's actually quite difficult to do in the data. We found one, maybe two examples where a Jupiter-sized world has a Neptune-sized world as a moon, but that feels like a different kind of thing. So another prediction you might make if you want to be special is that the moon will turn out to be rare. But apart from that, we're in this weird position where, at least as far as we know, we really are living on a planet which is normal, apart from Jupiter and the moon, but a planet that's perfectly normal, one of billions in the universe, and yet the unusual thing on it is us. And so even from a scientific perspective, we start to argue that we are in a special place in the universe. There's also another sense in which we're special. And Adrian, I'm assuming I've got about 7 or 8 minutes left. If I have less than that, you should tell me. So let's think about the universe as a whole. Let me show you a map of our neighborhood made by a telescope in New Mexico called the Sloan Digital Sky Survey. So this is sort of an intermediate perspective. So each dot here is a galaxy, and this is a map of our neighborhood. Ignore the fact it looks like a bow tie. The bits in between the bow tie are just parts of the sky that we didn't map with this particular survey. And I should have said, sorry, this isn't a telescope in New Mexico. This is the Anglo-Australian project. So this is a telescope in Australia called 2DF. But you can see the structure here. This is called the cosmic web. There are places where there are lots of galaxies. There are places where there are very few galaxies. And it turns out we sort of live in the cosmic suburbs. We live in a sort of Croydon of the universe, a place where there are some neighbors, but not too many. One of the things I love about the survey is that a couple of researchers, including a guy called Carl Glazebrook, decided to take this immense survey of what added up to about 1 million galaxies and reduce it to a single number. So he took every galaxy in this survey and he sort of plot them all on top of each other to try and answer the question, what color is the universe? If you take the light that we get from every galaxy and you average it out, what color do you get? And when he did that, they put out a press release and it was this color. Now, this is embarrassing for me because I'm in Oxford and this is pretty close to Cambridge blue. But it was equally embarrassing for, I can't believe I've done an Oxbridge joke. Sorry, that's awful. It's the end of the week. Anyway, it was also embarrassing for Carl and Co. because the thing you don't want when you put out a press release, so this story about the universe being this weird blue went everywhere. It was on all the news shows. It was on the front cover of several papers in the US and in the UK. It turns out they had a minus sign wrong in their calculation. And so they had to redo it. And it turns out the universe is actually this color, which I don't know how that's coming across the computer. It's a slightly off-white. They tried to save it in a press release. They said that this was actually cosmic latte as a color. But honestly, it's just slightly off-white. Now, why were they doing this apart from press releases and having fun? This is what astronomers consider fun. Actually, if you do this over time, and you look at galaxies in the distant universe, where we see them as they were billions of years ago, and then you repeat the process, the color of the universe tells you about the state of the universe. It tells you about how many stars are forming. And the news is really bad. So I don't know if you know this, but our universe is way past its best. So more stars are dying today than have ever been formed. More stars are dying today than are forming. The peak of the universe was about something like 10 billion years ago, where there were cosmic fireworks and loads of the galaxies were actively forming stars. Even our Milky Way seems to be slowing down. It seems to be quenching. And for having formed lots of stars in the past, we're kind of shutting down and shutting off and evolving into a state where the galaxies will just exist and be quiescent. So we're past the point that the universe really sparkled. And so that's kind of a depressing thought that we live. I want to live at a time when the universe is at its best and most active. We could clear the slides at this point if that's doable, people in charge. It's also the case that the situation is going to get worse. So if you look into the future, then this process continues. We are slowly running out of fuel. More galaxies are shutting down their star formation. And so we end up pretty quickly in a sort of steady state universe. That's the wrong words to use, but a universe in which there aren't any more stars and what we've got just decays slowly over time. Worse than that, we now know that the universe is expanding, but we also know that that expansion is speeding up. We don't understand why that's happening. We give it the name dark energy, but that's a label for something that we don't understand. And so the expansion of the universe is speeding up. And what that means has profound consequences for how we should think about things. Firstly, it means that the proportion of the universe that we can see is decreasing. So our observable universe, the little bubble that we get information about is shrinking. So in the far, far future, in a few 100 billion years' time, we won't be able to see anything beyond our galaxy. But it's also true that the ultimate fate of the universe seems to be a place where all the stars have died, all the black holes eventually evaporate. That was Stephen Hawking's great discovery. And we end up with just sort of sea of particles and radiation expanding ever faster forever. And so the last 10 billion years or the last 30 billion years turn out to be a really unusual time in the universe's history. It's the only time where planets that can sustain the likes of us will exist. It's the only time where stars like the sun will shine. We've probably got another 10 billion years, but that's a tiny fraction of what might be an infinite lifetime of the universe. And so I'm still not sure whether we live on a special planet, but I do know that we live at a special time in the universe's history. And that's the thought that bothers me when I step outside and look up at a dark sky and think about the vastness of space. I like being in this enormous playground filled with wondrous galaxies and stars and planets waiting to be discovered. But it bothers me that it's all decaying. And so I've thought quite hard about how to come to terms with that thought of this lonely moment in a cosmic history. And Rebecca Elson, who was an astronomer turned poet, or an astronomer and poet would be better, summed this up for me. She wrote in a poem called We Astronomers, she wrote that astronomers honor their responsibility to awe. And I think that's something that we all have. I think given that through whatever rolls of the cosmic dice, whatever winning tickets in the cosmic lottery our species happen to get, we get to stand here and look out at this moment in the universe where things are happening. And I have no idea whether we're special or not, but that thought makes me feel special. And I hope that next time you look up at a star in the night sky, or think about astronomy, or take part in a citizen science project, or notice that astronomy has made the news in whatever way, that you'll remember that it's your job to honor your responsibility to all, to pay attention and be impressed by the universe that we find ourselves in. Hopefully some of that made sense. I'm very happy to take questions on pretty much anything. So thank you very much.
Well, thanks very much, Chris, for slightly depressing us at the end. You're a practical astronomer, or at least you're an observational astronomer to some extent. What do we do to find out whether that is the case, that we are special? I mean, if you were setting up an experiment now to say, how do we find out whether we're alone, we're special? What would you do? And do we actually want to find that out, or is there implicit danger in that?
Yeah, no, there's a good question. Well, I want to find out. So let's start there, and then I'll remind me, and I'll deal with the danger point. So I think the way to think about it is we're on a journey. So the first question in determining whether we're special are there planets out there that life could exist on? And the answer is definitely yes. We know that now. So the next question is, which of those planets have conditions that might be suitable for our kind of life? And maybe there's other kinds of life, but if we restrict it, we now know that there are lots of those planets. So now the next question is, which of those planets do have life? And we're going to make progress there too. So the extremely large telescope that I talked about. So this is a thing that's being built. The mirror is 40 meters across. The dome is being built by a company that normally builds football stadiums. So imagine the Millennium Stadium in Cardiff or something, but with a telescope.
This is a synoptic.
This is the extremely large telescope.
Extremely large.
So we'll come to LSST in a sec. So that will look at the atmospheres of some nearby planets, and for example, we might be able to tell if there's oxygen in the atmosphere. And on Earth, oxygen is produced by life. So if we knew there was an Earth-like planet in this zone around the star that's the right temperature that had oxygen, then maybe we could conclude there's life there. And then we've got to find people to talk to. So that's the hard bit. And you sort of end up in a sociology problem. So you go from understanding the astronomy to understanding the biology to going, why won't they talk to us? Yeah. And that's where the is it dangerous piece comes in. So my working assumption is that any civilization with the technical ability to do us harm, to cross interstellar space and invade or whatever, to steal our water or whatever, they already know we're here, because we're close to being able to detect planets. So I think we shouldn't worry too much. I will say, just for this audience, that the most powerful signal ever sent into space, genuinely, was an advert for Doritos. And so if the aliens do turn up, it was the cheese flavour. And normally I keep the flavour to myself, but just so you know, that's what they're after.
We've got a question here from, and I know this is a problem you've had with your citizen science, that people kind of have their handles rather than their real names. So
sure, that's fine.
MWWQOS123. In the 4.5 billion years of the Earth, it is only the last 100 years or so in which we've had the technology to transmit signals into space, and we may not be here much longer. A factor?
Yeah, it's a good question. So there's a whole category of solutions to this "are we special" problem, which I put in the box of these are depressing answers. And one of them is that you just say, okay, but every time life gets started, before you get around the same time you get the technology to broadcast to the cosmos, you also destroy yourselves. And then what you have is a galaxy where there are brief flashes of intelligence, but you're never close enough to talk to each other. Now, the reason I don't like that answer is I'm, despite the end of my talk, an optimist. I want to believe that we're still going to be here in tens of thousands of years, and so I'd rather not reach for that. But I agree that that's a possibility. Actually, there's also the sort of technical version of that, which is that we're already going quiet from a radio point of view. So in the 60s, big international television events were broadcast globally and out into space. Now it's all targeted because it saves power. And so the period of time in which we were loud in radio waves in the cosmos was actually rather short. So that's why people are thinking about things like detecting radar. So if you could detect an airport radar, you want an airport radar as a signal that you broadcast because you're trying to find planes. So if you can find that signal, you might pick up. So there's also the, maybe tomorrow we'll invent, the Lintott wave, which is some quantum means of communication, which it turns out everyone else in the cosmos is using. But so there's also like, how long are you broadcasting to think about as well.
And do you think, I know in your book, which I know is a couple of years ago, that you talk about having just hired a biologist to your team. But do you think if we do find a life, would we recognize a life form? In Star Trek, they're always talking about silicon life forms, and would we actually understand that's
it's a good question. They also, in Star Trek, of course, they have the magic scanner, which for purposes of plot immediately tells you whether something is alive. So no, astrobiology is a subject. You can do university courses in it, and there are people who will tell you that their job title is astrobiologist who are trying to think about these things. So, and I think I was careful to say that we're only thinking about life like ours, because that's easy to imagine. If you go back to the great Cosmos series with Carl Sagan, which had jellyfish swimming in the atmospheres of Jupiter and breathing hydrogen, I think it becomes very difficult to ask this question scientifically, because then you say, what conditions does life require? No idea. And so I think we'd recognize our kind of life. Whether there are others out there, some of my favorite science fiction talks about different timescales. So one could imagine life that exists on millennia timescales with very slow reactions, and understanding how creatures like ourselves, which are things of milliseconds, could interact with that sort of life would be very difficult. But let's start with trying to find our own kind, and then we'll work outwards from there, Star Trek wise.
There's a point that you made in your talk where you were talking about the moon, and I'm going back to thinking about Emily Levesque's event that kicked off Big Bang Week. And she talks about this idea about the moon, about having a total solar eclipse, and that the moon, this potentially meaning that if you're an alien, that this would be a very special thing. But I like the idea that this is it's not a coincidence, that it's the moon that's influencing the tides, and the tides are perhaps creating the possibility of life. So it might be the other way around.
That's right. And actually,
there are determining things.
There are people who go further and say that so there's this apparent coincidence that the moon is about the same size as the sun in the sky, which I guess Emily was talking about.
Yeah.
And you should definitely all go and watch her talk on YouTube. It's fab. So this is a coincidence, and a beautiful one. And if you ever have the chance to go and stand in totality, you should definitely do it. It's a remarkably eerie awe-inspiring feeling. To watch the sun disappear, it's beautiful, but there's also the bit at the back of your brain going, where has the sun gone? Where has the sun gone? This is weird. And then it comes back and it's a lovely feeling. So anyway, go see an eclipse. But you can argue that coincidence of size also means that we get variation in tides. So you get spring and neap tides because both the moon and the sun have an influence. And so that means the range of places that are affected sometimes by the tides is bigger. And so people have argued that that's actually how life on land gets started. So maybe what we'll do is get better at finding moons, target the systems where the moon is the same size as the sun in the sky, and that's where we'll find life. Who knows? It seems a bit speculative to me, but I like the argument, and it's kind of fun to think about alien eclipses and other places in the galaxy that we could go to watch them.
Great. Andy's asking, how do we get our heads around planets that can and will harbour intelligent life, but they're 100 million years behind us, and they haven't evolved that far yet? I mean, I suppose that's not really an ethical. Well, maybe it is an ethical question even now, but
I think there's a sort of sense of planets as wildernesses. So I think that the ethics bit at the minute, I'm reasonably uncomfortable with the idea that we're going to send people to Mars, because Mars may have I'd rather have it as a beautiful wilderness than a theme park, and B, there may be a fragile ecosystem that still exists on Mars. We're careful enough that the places on Mars that could still harbour life today, there are a few places where there appears to be water under the surface or so on. We won't send rovers there because we're worried that we might contaminate them. And so sending a bag of bugs and flesh like myself is not a great idea to a place where you're trying to preserve the biology. So I think even on Mars, we've got that worry. I think the other thing to worry about, though, is if there are places where the planets are 100 million years behind us, there are probably places where there are planets are 100 million years ahead of us, where we should expect, if life is common and intelligent life is common, we're not going to be top of the class. And so it's the absence of those advanced beings zooming around the cosmos in the Starship Enterprise or local equivalent that I think is a big mystery. And that's what gives me the sense that maybe intelligence is rare, even if life is common.
Now, I mean, obviously, one of the ways we've talked about you exploring this kind of thing is through observation. But I guess the other one is just pure mathematics and just saying probability. What does that specifically? What does that tell you about life? The kind of probability that people like Nick Bostrom deal with when they're talking about intelligence.
Yeah, I think one place where that's interesting, I think, is to think about the history of life on Earth. So I've talked about what we can see in the universe and use that to talk about how we can think about life in the universe. But we can also go the other way. So we know, for example, that life got started on Earth pretty quickly. The oldest fossils are 3 and a bit billion years old, and probably life goes back before them. So if life got started quickly, then presumably that tells you that it's quite likely. Like if I toss a coin twice and I get heads the second time, I can conclude it's reasonably likely that I get heads. If I buy 2 lottery tickets and I win one, then it probably tells me not many people bought raffle tickets. So that works. So I think you can play this game. So Simon Conway Morris from Cambridge has a brilliant book on this where he looks at convergent evolution. So things like something like the eye has evolved 17 times independently that we know of in the history of life on Earth. So that probably means it's quite a good solution to the problem of living on a planet. So when we meet aliens, they're probably not going to have satellite dishes instead of eyes. They're probably going to have something that looks a lot like an eye that's used for sensing light. But intelligence, even at the sort of gin and tonic level that I'm talking about, has emerged once, and it took more than 4 billion years to do so. So maybe Nick may well argue, and others have argued, that means we're rare, and that you need to buy many lottery tickets to end up with one of us. And so maybe the thing the filter that we've come across is we've got this far, and so then we can have this glorious starfaring future because we're not inevitably going to die. It's just that we've already won the cosmic lottery, and so that's an interesting idea. I think we test it by more observation. We can go out and look and see which planets. I mean, I think if that's right, there's a slightly depressing future in which we get to explore the galaxy, but we don't find any friends. And we find planet after planet with Earth-like life and no one to talk to.
We've all been to parties like that.
Well, exactly. Yeah. I guess. Do you want the party with no one there, or do you want the party where you're in the corner and you don't understand what's going on? So maybe it's a personality type. So we should select loners as astronauts. It's probably not a bad move anyway.
I suppose for a kind of amateur, the mathematics cuts both ways, because you can think, well, 100 billion stars, 100 billion galaxies, and you can think, well, that makes it really unlikely. Or you can feel like, well, just run the numbers, and
it's almost a personal choice, right? How to think about that. There isn't both of those options are scientifically valid right now. So I think this is an interesting area to talk about, because it really does come down to how we feel about our place in the cosmos. And I do think that I do seriously, where I ended that, and I think a lot of the citizen science stuff, the joy of putting projects online so that people with just a laptop can do something in a lunch break in 5 minutes at work when they're supposed to be doing something else, can contribute to understanding the cosmos. I genuinely think that's in some sense good for the soul, right? To be part of humanity's effort to try and understand where we are is good for people, I think.
I want to come to citizen science. I want to come to citizen science in a moment, because I think that's a really interesting part of what you do. Tell me a little bit about how you began to get into that. Tell me about Galaxy Zoo, which was your kind of foray into that.
Yeah, so in some sense, citizen science is a slightly obscure label for anyone participating in science. It's something I've kind of always done. I grew up as an amateur astronomer. I was in the back garden counting meteors and sending those off to the International Meteor Association, who keep counts of such things and so on. But Galaxy Zoo was something that started when I arrived here in Oxford in 2006, when we had 1 million images of galaxies from the survey that I was talking about that produced Cosmic Latte and the Cambridge Blue and so on. We had a student who'd looked at 50,000 galaxies and had just spent 2 weeks going spiral, elliptical, spiral, just sorting them out by shape. And he'd shown that he was better than a computer at doing this. And we were trying to understand the history of these galaxies, and this is useful information. But he really didn't want to look at another 950,000. So without really thinking about it, we created a little website and put up the data and just asked people to help. And we thought, my idea was I'd give a talk like this, and you'd all go and classify 20 or 30 galaxies. And next month I can give another talk, and it would be the slow build-up. In the first day, we were receiving 70,000 classifications an hour from hundreds of thousands of people. This sense that you could do something to help us understand the cosmos really clicked with people, and that was the beginning of my very distracted adventure in citizen science, because we realized that not only was this useful from the science point of view, but it also really tapped into a need that people had to contribute and to be useful. We had a really busy couple of years in the last couple of years, because I think those who did have spare time in the pandemic wanted that sense of contributing to something. And so the projects that we run, like Galaxy Zoo or Planet Hunters, which I mentioned, give you a really easy way of spending a few minutes and connecting to this collaboration to understand the universe.
Yeah, one of my favorite bits in your you've got this chapter where you sort of talk about the historical beginnings of citizen science, and there's some brilliant and sometimes misguided projects in there. There's particularly, I think it's Benjamin Robbins.
Oh yes, in watching the fireworks in Green Park. So he was trying to understand artillery, and there was this argument about whether, when you launch a rocket, whether it goes straight up and straight down, or whether it goes this way and then suddenly drops, or, as we know, goes in a parabola. So there's this big fireworks celebration in Green Park in London. Actually, it's the Handel wrote music. It was a big deal. And Robbins asked people through the pages of a magazine called The Gentleman, if they could see it from their house, could they please measure how high in the sky they were, because then he'd know how high the rockets were going. And there were 3 pages of instruction, which included recording the position of the rockets against a distant church and then sending your servants out the next morning to measure the height of the church and so on. So, there's a certain class of person who's involved here. But he got no replies, apart from one from an angry Welshman who had been in North Wales and claimed that he could see the fireworks from London and was insistent that the government had wasted an enormous amount of money. Because if you could see the fireworks from Wales, then I think from Aberystwyth in particular, then it must have been a waste of money. So I think that's the earliest crowdsourced citizen science project, and it was an abject failure. And it started a long history of several failed projects. But things like the Met Office owe its beginnings to a bunch of people who recorded rainfall and weather data as volunteers, and there's all of that stuff. In fact, that's Robbins as well. Sorry, I forget the name.
That's Glacier.
Glacier. That's right. Yeah. This is the problem with the book you wrote a few years ago.
Well, I've just read it, and you
yeah.
Years ago,
but that network's incredible because they even get that network of volunteers who were sending information via the railways in collaboration with papers who could then report on where was the sunniest in England and so on. They got really upset when the Met Office was founded because they felt that professionals couldn't do a proper job with this data. And we see some of that with some of the galaxies who volunteers know their stuff, have learned things because of the project. And quite often there's a sense of like, come on, university lot, you get out the way. We're doing the real stuff here. This is my galaxy now. I found this interesting thing and let me work on it. And that's brilliant to see.
But the flip side, I think you said there was one chap in Stornoway who was then employed by the Met Office in London. He was the first person outside London to be employed.
That's right. He was
and then he stopped being a citizen scientist because, of course, he wasn't going to do it for free. Now. So
right, exactly.
Constant bind of.
Yeah, and I think we've had interesting conversations where, with some of the, particularly on Planet Hunters, actually, where people think they've discovered a planet. That's an exciting thing, and it really is. And but there's some work we have to do to follow that up, and we've built better systems over the years. But at least in the early days, we were having to explain to people that, just because I'm an astronomer, like I also have to answer email and do admin and find out. Like, I can't today confirm whether you found a planet or not. We have to apply for telescope time and so on. So it's been interesting to sort of connect those things. One of my colleagues, Bill Keel, who's a Galaxy Zoo person, he's a brilliant observational astronomer of the old school, talks about citizen science revealing to people that the Hollywood version of science is fake. Like, it turns out we don't all sit in a big conference room and then somebody go, I've got an idea, my God, there are planets everywhere. And then we all cheer. Like, it turns out it's a lot more day-to-day grind than that at times. And so these projects become an interesting way of talking about that. It's sometimes exciting that we accidentally discovered the Earth in Planet Hunters, which is a whole other story. But that was about a month-long saga, and we eventually just had to publish a short paper that said, sorry, we have found a planet, but it is the Earth in the background of some of the images from the space telescope. So
I loved in the... Sorry, Karen.
No, after you. No, go on.
I loved in the book your little pen portrait of Darwin, who I would never have thought of as because one always thinks of sort of Darwin on the Beagle going out doing the work. But actually, you present him as a kind of proto-citizen scientist because he went back to his wonderful, if people haven't been there, his wonderful house in Kent, which you can still visit today. And he sat there and he had letters coming in every day from people around the world, which was both a kind of, I don't know if it was a joy to him, it was an obligation to him. It seemed to be an obligation to a lot of his correspondence.
It was both. People definitely wanted a letter from Darwin after he became famous. There was definitely this sense of, wanting a letter from the great man. So there's a lot of speculative, like, I must tell you that in this part of the world, we have a striped polecat, which I'm sure will interest you. And I think that stuff was a chore. But there's also evidence in the letters, and all his correspondence is online. So you can go and look at letters. I recommend there's a random letter button on the site, which is great fun. But they're often him saying things like, you're from New Zealand, please tell me, what's the weather like in January? I hear there's a stoat-like object that lives in the woods, please tell me about it. And what's the local word for hazelnut, or whatever it is? And he's using this network as his information gathering system, because he was ill a lot of the time. He hated company and people. He'd be fine in our empty cosmic party, and so he needed his information on the world from this network of correspondence. So yeah, I think that's really interesting. It reminded me a bit of the closest equivalent who I talk about in the book is my friend Tom Hart, Penguin Tom, who calls himself a penguin. He calls himself a penguinologist, so he's on the BuzzFeed list of people with great job titles. But he has this network of cameras in the Southern Ocean on the Antarctic Peninsula. But if you go there with Tom, he knows absolutely everyone on all the ships. And he's always on the radio going, oh, well, if you're going over there, could you just pop in and change the battery on that camera? And then half his stuff is stored in random shops in southern Chile because he knows them. And he's just got this amazing network of people who are all participants in his science and all contributing to his understanding of penguins and their populations, which all I learned from going was that penguins smell awful. It's absolutely disgusting.
You do learn a lot about that in the book. You learn a lot about penguin guano, penguin pee. It's including its evolution, potentially its evolutionary purpose. It's
not a normal astronomy book.
All of human life is in this book. And I should say, because we're a book festival, the other thing I wanted to ask you about don't worry, we will come back to astronomy in a minute, but it was about Shakespeare, because even Shakespeare comes into your Zooniverse, doesn't it?
That's right, yeah. So one of the things that happened, to get from Galaxies here, we were doing these astronomy projects, but we started to get other scientists and researchers who needed a crowd of people. So Tom, if you go to penguinwatch.org, then you can help Tom count penguins. Which is an insanely popular project because 5-year-olds can take part in that and do, and it's great. So we ran a project looking at not at texts of Shakespeare, but 60 texts from Shakespeare's world, from his contemporaries, describing everyday life, and the task is to transcribe them because the handwriting is old and machine learning can't, at least to begin with, deal with this. So my favorite bit, that's the recipes. So the volunteers found a whole set of recipes, and there's now a bunch of people who now cook these recipes, and they're pretty bland but perfectly edible. And so this is great fun. We found, and then they also found like the oldest use of the phrase "a white lie," which is now in the Oxford English Dictionary. And so again, these projects, people start off with the motivation of wanting to help. And then they get into a task, whether that's penguins or galaxies or Shakespeare's world or whatever. And then suddenly people find that they're interested in all this stuff that they never thought they were interested in. So that they're sort of engines of motivation, these things. Suddenly you find yourself deeply interested in 16th century pastry, or the properties of green galaxies, or the post office that appears in some of Tom's penguin images, the only post office in the Antarctic. And so people go down these wonderful rabbit holes.
I'm going to take two questions together. One is mine, and one is another one from Andy. And Andy asks, when will AI overtake the human brain's ability to do citizen science, and will we still be special then? And my one, which might not feel connected, is how do you make sure that your citizen scientists they're not just drudges? They're not just, you can't be bothered to pay them to do the work, that they're getting something out of it that is actually more meaningful than just pointing at a screen.
Yeah. So I think the second one is easy. So it turns out that for every time we've asked our community what they want, it's contact with the scientists. They want to feel part of the collaboration. So the best projects are ones where the scientists are active and can answer questions and invite volunteers into their meetings and to be properly. The joy of doing the job that I do is that just occasionally. This morning I had a wonderful conversation with Becky Smethurst, who's an ex-student of mine. She's a research fellow. YouTube's Dr. Becky, if you haven't seen it, people. But we found out something about black holes that completely confused us. And all day I've been sitting here thinking about whether this result can be right and whether there's something wrong and whether that changes what I know about black holes. I'm not even going to bother telling you what it is, but I've had such a good day because I've got to think about that. And I think making sure that the volunteers get that as well as the it's a spiral, it's an elliptical. I think that's really important. We also give them credit on the papers and so on, but it's it being involved in the mind-blowing thinking and the feeling that you know something that other people don't yet. The AI question is interesting. It's a lot of the work that I do at the minute is incorporating machine learning into these projects. So on Galaxy Zoo at the minute, there's a machine running in the background that has opinions about what it needs you to classify. And so you're seeing the galaxies which most help the machine. And what that means is the machines do the boring bits. And we humans get the interesting and confusing and distracting and complex things. So I'm hoping that it will make the task more interesting but we're always going to need this sliver of data to be reviewed by people. So I would bet that we're still running Zooniverse projects in 10 years' time because the machine won't cope with the data that's coming our way.
Well, we're heading towards the end, but I want to come back very much to this question of, are we special? And looking at life on other planets, do you think we are going to find that life soon? I'm not talking about little green men. I'm talking about microbes under the soil in Mars or whatever, Titan or wherever we happen to go. And what do you think that will do to us as a civilization, as a society? I mean, this is not really an astronomical question. It's a physiological question, I guess.
So I think we're 10 years away from having in 10 years, we will have had a good shot at this. We will have sent probes to Mars that dig under the surface. There's a European probe nearly ready to go that will start that process. We may have got some Mars rocks back in this time, so we can get some stuff into the lab. And we will have this extremely large telescope which can review nearby planets. So let's say that in 10 years' time, I think we might be able to point to a star in the night sky and say that has a planet around it that seems to have life on it. I don't expect that to have any effect on our civilization whatsoever. I think it makes the universe vastly more interesting to think of a cosmos where life might be common. But I think we're introspective enough that unless A, the aliens turn up and want to buy Doritos, or B, they turn up with something pointy and sharp and threat us, I don't think human culture will change very much at all. But I really want there to be abundant life in the cosmos. Well, who wouldn't want a universe that's more diverse and more interesting? And I think we're a decade away from knowing that that's the universe that we live in.
Well, I think finishing on that point of a diverse and interesting universe, a lovely place to finish. I'm going to say thank you very much, Chris, for taking the time today to come and talk to us at Big Bang Week. I'm also going to show this book again, The Crowd in the Cosmos, which is a great read. And it is also one of the only books where the footnotes, you don't look at the footnotes with a slight sense of gloom. Every footnote is normally full of some kind of zinger. It's a lovely book. And we'll teach you about all sorts of things, 19th century naval history, weather observation, not just about astronomy. We'll be back tomorrow with a full program of events for Big Bang Week and on our final day. But in the meantime, it's just left to me to say thank you so much, Chris Lintott, for fascinating talk.
Thank you very much. It's a pleasure to be here.